Now we continue to how to identify the centroid by using integration. Here is the formula how to define the center of gravity or G to the respect of X and Y axis. And also we can replace our W to volume, area or length respectively. Now let's do example 6.1. For this shaded area in blue, we need to determine centroid of this area. And the function given here, y equal to x cubed. This is x-axis and this is y-axis, up to 1 meter on both axes. Now, what we have to do, we need to cut or slice into very fine element. So this is very fine element where the length on x-axis is dx, while the height for this element is y. So for this fine element, where is the centroid for the pink area, or we can call this is rectangular. So the centroid is here, where we can know the location from x-axis is x, while for y is y divided by 2. So this is the centroid for this small or fine rectangular element. So with this small pink area, with this small rectangular area, we can find area for that element, which is dA equal to y times by dx. So that area for this small rectangular, we know our y is x cubed, therefore dA is x cubed dx. So we define area for that thin element. Now we need to find centroid for this thin element. So on x-axis, x prime is x, while for y prime is y divided by 2. And we know y equal to x cubed. So we substitute, we get x cubed divided by 2. Back to the basic formula explained earlier. X prime is integration x dA divided by dA. So we have our x prime, so we need to substitute. And also we know our dA. So our x prime is x, our dA is x cubed. So for that one, and dA is x cubed dx. So we have to integrate this. So we have x power of 4. So we integrate x power of 4. We will have x power of 5 divided by 5. So we have x power of 5 divided by 5. Then you need to integrate x power of 3. So we will have x power of 4 divided by 4. And the limit for this integration between 0 to 1. Therefore, for both, integrate between 0 to 1. So we will get, for the upper part, we have 1 divided by 5. And the lower part, we have 1 divided by 4. Calculate that, then we get our x prime is 0.8 meter. Next, we going to identify our x prime. So this is the formula as I explained early on. So we substitute our y. So our y prime is y divided by 2, or x power of 3 divided by 2. So this is our y, x cubed divided by 2. Then our dA is x power of 3 dx. Divide by dA, our dA is x cubed dx. Calculate that between 0 to 1. So we get our prime is 0.2857. Now for this one, once we get our answer, we can round up to 1 decimal place, so equal to 0.3 meter. Therefore, we get our centroid is 0.8, 0.3. So we need to identify where is this point on our graph. So on x axis 0.8, so here is 0.8, while for y is 0.3. So here is our centroid with the coordinate of 0.8, 0.3 on x and y axis respectively. So next, you can try to do example 6.2. Previously, we sliced it vertically for our element. So we have dx, so height is y. Now we have to slice it horizontally. So we're gonna have dy and we have x. So try to this example by yourself, and the guided answer for this one given in your notes.